Dear students, this is the MCQ from the units and measurements. It is clearly given that the equation of a wave is given by y equal to a sin of omega of x by v minus k, where omega is the angular velocity and v is the linear velocity. Then we have to find the dimensions of k. From the principle of homogeneity, the dimensions of x by v is equal to dimensions of k. From this, the dimensions of k is equal to, we know that the dimensions of the x is L and the dimensions of the v is L t power minus 1. So, the dimensions of k is, finally you will get the t. So, the option second one is correct. Dear students, this is the second MCQ from the units and measurements. It is clearly given that a physical quantity x depends on quantities y and z as follows. X equal to ay plus b tan cz, where a comma b and c are constants. Which of the following do not have the same dimensions? From the principle of homogeneity, already the equation is given x equal to ay plus b tan cz. So, from the principle of homogeneity, the dimensions of the x is equal to dimensions of ay is equal to dimensions of b, as well as the dimensions of c is equal to the dimensions of z inverse. From this, x, the dimensions of the y is equal to the dimensions of the x by a is equal to the dimensions of b by a. Clearly we got that the dimensions of the x and the dimensions of the y both are equal. So option 1 is wrong. And the dimensions of c and the dimensions of the z inverse is also same. So the second option is also wrong. And the dimensions of the y is equal to dimensions of the b by a. So that third one is also wrong. The dimensions of the x is not equal to the dimensions of the a. So that the option 4 is right answer. Dear students, this is the third MCQ from the units and dimensions. See, if energy E and velocity v and force F be taken as fundamental quantity, then what are the dimensions of mass is asked. Okay, see, let mass m is directly proportional to energy power x, velocity power y, force power z. By substituting following dimensions, the dimension of the mass is m is equal to the dimensions of the energy is m L square t power minus 2 power x, and the dimensions of the velocity is L T power minus 1 power y, and the dimensions of the force is ML T power minus 2 power z. By equating both sides, we will get the value of x is 1 and the value of y is minus 2 and the value of z is 0. From this, the dimensions of the mass you will get e power x means x equal to 1 and v power minus 2 and f power 0, no need to use. So finally, the dimensions of the mass is e v power minus 2. The second option is correct.